slides, right? Is that correct?
Yep, I can see it at least.
All right, great. I'm going to go and kick things off again. Thank you, everyone, for joining the third edition of the Salesforce Security Office Hours. And just to kind of just run through the agenda again. We always go through so far. What are the Salesforce security officers? Why does this exist? Rules of engagements. I'm going to introductions and then a recap of last week's session. Also, give you a little bit about the topic that Mika here will be talking about. And also, I have a new section I added called Hot Off the Press, which is recent news and events that have happened since the last week that we can talk about. And at the end, it's Q&A. One thing that here I'll go ahead and read the statement because this is something I think is very important just for everyone why that we're doing this and why this exists. So Salesforce Security Office Hours was created in response to a troubling reality that data breaches in the Salesforce ecosystem are increasing and not declining. Too many organizations are losing sensitive customer data to attacks that could have been prevented, and these sessions are exist to create that, and that's why I decided to start this. Every week, the whole idea is we're looking at real world breaches and share specific Salesforce security best practices that are presented by security experts that can provide you with practical, actionable steps that you can take today to strengthen your data security and reduce the risk of a breach in your own Salesforce environment. What that really means is this is a forum that allows you to learn about best practices in Salesforce security, but also engage. So you can feel free at any time to ask questions. I've made it so every one of you can speak. So if you have any question, don't feel free to interrupt and just be able to ask the questions of speakers because this is an open forum and that's the whole point of this. All right, so just the rules of engagement, be respectful to others. So if someone is talking, please try not to talk over them. If you have questions, try to raise your hand, but also, like I said, feel free to interrupt if if we don't pay attention to the hands up. And then take notes and take something actionable way that you can do today and make a change in your environments. All right, so who am I? I am the CEO and founder of EzProtect. I'm also a certified technical architect with over 18 years experience in Salesforce. I'm also the bestseller of this book here, Securing Salesforce Digital Experiences. It's about a real life story where a customer of mine on a project I was got breached. So this is real to me. That's why we're doing this. This can become real to you, and hopefully this doesn't happen to you. Also, I'm a founder and member of the Low Code Security Alliance, and spend most of my time all on Salesforce security. Mika, here, I'll let you go ahead and introduce yourself as well. Then we'll continue on to a couple more slides, and I'll give you the floor.
All right. Hey, nice to meet you, everybody. I'm Mika Ståhlberg. I'm the co-founder and CTO of Valo. And yeah, I have a long experience in cybersecurity. My previous role was the head of security at Aura, the makers of these smart rings. And before that, I was for a long time at F-Secure, including roles from a researcher into the CTO. And yeah, if you want to look at the research that I've done and the things that I've published, you can go to Valo AI/blogs and read about it. So I blog about security topics in Salesforce. Looking forward to the discussion.
All right, great. And then Mika will be talking about some things you can be doing to better protect your org with permissioning and what people are doing. I think the gaps in the permissioning in Salesforce, right? I believe.
Absolutely. So Valo's solution is about monitoring the security of your Salesforce, but also about managing the accesses as well as adoption. So access controls are very near and dear to my heart and relatively complicated in Salesforce. So that's what we'll be talking about today.
Yeah, same here as well. I'm that's one of the things I talk about all the time is about the misconfiguring of your Salesforce environment. So this is why I thought it was important to bring Mika today to help talk about that. So let's go and just do a quick recap from last week. So last week I talked about answering the question of why is it, or posing the question, why is it that there's no dedicated security roles in Salesforce organizations? And I mean, the base problem at the end of the talk really was that IT security teams, they know these really nice security frameworks, but they don't know Salesforce. Whereas Salesforce teams know Salesforce, but not security frameworks. And executives think both are covered on both sides. And this creates gaps in how security reviews are being performed and also, on all the different what people are really looking at security environments. So if you're interested, you can watch last week's session to get a little more insight to that. So the hot off the press here, this is something I just picked up on yesterday. So we have a new breach that happened yesterday. It's Chanel got breached. It's very similar with all these other breaches we've been seeing lately. It was a vishing and phishing attacks where the attackers with shiny hunters convinced them to download a malicious app through Salesforce. Is probably the same fake data loader app or similar that they got them to install in their org, which gained access to their data. It's still a developing story, so there's not too much information on this, but their sources have confirmed that was Salesforce that was compromised, and then sensitive personal information from U.S. customers were exposed. And the one thing that makes important of all these breaches is that this is not this is not sales a I would say not a breach in Salesforce itself, but more of customers misconfiguring Salesforce environments, which again is why we're here doing this today. And just a couple metrics. I just like to share metrics always because I think they're important to learn, see what's going on in the world metric wise. So that 30%, 6% of businesses experience a data breach of more than $1 million, costing more than $1 million. And this is increasing 20% year over year. And there's a lot of different, the cost of the breaches are just astronomical. I mean, I think that the average, according to IBM, is 9 million a year. But I read something, one organization of one of these breaches, and I don't remember which one, said that they estimate their over total costs after the recovery is going to be around 400 million. So these things are not cheap, and it's really easy. Well, not easy, but it's possible to help avoid these breaches if you are, paying attention to your Salesforce environments and what's going on in them. Also, I have a question for everybody here. What do all these companies have in common? And this is not our customer list right now. So anybody have a guess? Someone speak up, please. What do you think these have in common here? Anybody?
They all had data
Wait.
breaches.
Yes, exactly. Good job, Martin. Yes, these are all companies that recently have been involved in data breaches. This is not a slide you want your company on, but also this is just to give you an idea. I mean, these are big names. I mean, these are companies that have really big security teams. And so, but yet they're being breached. So imagine, if you're a smaller company, you're probably even more at risk because you don't have those resources. So this is just why we want to, just again, surface that be always thinking about security and the mindset so you don't, show up on my slide. All right. So now on to the topic for Mika. How is poor Salesforce permission management exposing org to cyber attacks? So Mika, I'll let you have the floor and you can share and with your presentation.
Yeah, so essentially, you can look at any breach or any attack in different phases. There are like different terms: kill chain, attack chain, whatever you want to call it. So essentially, there is in the very beginning, there is an initial access phase where somehow the attacker gets access into the org. And in these breaches that we had in the discussion here, like the ones where we know how it happens, it was phishing or vishing or like this sort of voice phishing, where the attacker basically tricked the user into connecting a connected app into their Salesforce org. So that's one technique which is now very prevalent in the Salesforce world for the initial breach. This, like in the Microsoft world, this has existed for a while, and it was called consent phishing, which is probably a fairly good term for Salesforce as well. So you're phishing for consent from the user. And after that, there are different phases, lateral movement and all that. And then there is the data exfiltration. Because in these attacks, like the target of the attacker is to exfiltrate data so that they can extort the victim. And therefore, they kind of go through this kill chain. And access controls are actually quite important in every part of this chain. So when it comes to the initial access, so if you think about how does the attacker here get access to these orgs, for connected app, you can use API access control or similar things to prevent new connected apps being connected to user accounts. That is a sort of an access control, and so you can restrict that. You can also restrict it by IP, but of course, in today's world, especially in smaller organizations, they don't really have a perimeter like a VPN or something like that necessarily. Like IP addresses are a challenging thing, but you can use the connected apps, or you can monitor the connected apps and remove all the connected apps that you don't want in your organization if API access control is something that is, let's say, too labor intensive, because it requires quite a bit of work to
and Mika, quick question for you here. So most of these breaches, and that's great that you talk about the connected apps, because I think if most of these breaches that are happening right now is actually through a connected app that was created, that was a fake data loader. Is that right? And what's going on right now? And kind of basically what's happening is they're asking for a code, pretending to be the IT department. They give them the code, and then they're able to connect that app into the org and get access to the user's data. So kind of what you're saying here, there's a couple things that people should be or could be thinking about. So first off is if you are able to do that IP-based security, because even if they're using the connected app and trying to connect connect with the API, but if you have the IP-based security, even with the connected app installed, they still wouldn't be able to get to the data. And that's not a surefire, not completely foolproof, but it is a lot better than not having that in place. And then also, I know there's also there's the ability now that you can whitelist connected apps with Salesforce, but you have to open up a ticket with Salesforce to do that. And I don't have it in this call, but there are a couple others. I think I posted a link to that. And so that's something that you could do as well, is contact Salesforce to whitelist these connected apps of what's actually allowed to be installed into your org. And that's something I feel that should actually be default and not something that you have to contact support for. So
yeah, and that's exactly the API access control feature that I was talking about. So it's actually a feature that when you go to Salesforce setup, it's sort of not there. You need to ask Salesforce support to enable it. And the reason why a lot of companies chose not to use it, or maybe they don't even know about it, but it requires quite a bit of work, because there are lots of connected apps that people are connecting, and then the maintenance of that list can take some work. So that is definitely like you described. The thing though is about this attack, we don't know all the details. There is a Google threat intelligence report that describes this pretty well. So it seems that the attacker is using Data Loader, and I'm a security guy, and I know Salesforce, but I have actually, the first time I used Data Loader wasn't that long ago, maybe like a year ago. I didn't want to use like client-side tools, but then when I tried it, I was kind of surprised that it shows you this when you choose the OAuth authentication. It shows you this thing where it asks for these 8 numbers that are also shown in the app. And then I was wondering, like, I know OAuth flows in Salesforce. I've never seen this. And somebody correct me if I'm wrong, but I think it's the IoT device flow designed for smart TVs. So something that I would like Salesforce actually to do is that I would like it to be possible for me to disable from my org this IoT device flow. I'm not going to use it for anything. So that would be something that would be nice if it could be disabled.
Yeah, I was curious about that as well, of the code, because that doesn't sound like a normal OAuth flow. But I'm wondering what it might be is also might be like a one-time password, because you can go into the org and get a one-time password for APIs. And so that might be providing that as well. So I think that's something that would be nice to look into for a future talk, is how this attack is actually being performed.
Yeah, but Data Loader, like when you use it, it actually shows you that. So that's how you connect Data Loader. You have to read the digit code from the desktop app, and you need to pipe it into your Salesforce. And that's what the attackers are here tricking their victims to do. So I'm guessing that it doesn't really feel like that they're doing anything too bad. So maybe if somebody would ask you for your password, you would be thinking, oh, this is like, I'm not going to do that. Or if somebody would ask you to log into some web page, it probably, for many users, it would be like triggering some alarms. But then if you just have to go to Salesforce and type in 8 digits that the person on the phone is telling you, then maybe it doesn't feel too scary. So that's just my take why this attack has been sort of.
And I think this is something that's, I mean, phishing has been around for a while. For everyone, I keep saying phishing, but phishing is basically phishing over phone. So someone calls you up, pretends to be someone that you know, maybe your IT department, and then asks and then tells you, hey, we need to do an upgrade to your computer. In this case, they were doing a fake version of Data Loader that was compromised, and trying to get people to install that so they can get access to the org. And so I think, obviously there's only so much you can do. There's always that human component, and that's your weakest link in any organization. So what part of what you need to be aware of is just thinking about, how do you train your employees? How do you educate your coworkers? So even if you're not an executive and you're not management, you still have the ability to educate your coworkers about these things going on. Let them know that, hey, if someone calls you, make sure that you authenticate who they are. Maybe instead of if they called you, and then I do the same thing with my bank. As someone calls me, hey, I'm from your bank. What's your birthday? Can I verify it? I say, oh, no problem. I'll call you back. So then I go to the bank's website that I know is the right number, and I call them back, and you can do the same thing. So if someone calls you saying, we're your IT department installing, don't say, what's your number? Can I call you back? Go up and get the published IT number, call them back and say, hey, someone just called me, install the app. Is this real or not? And I think that's the best way to do it. But then, of course, you can't stop everyone. And that's why those other controls we're talking about come into play. Having IP-based security, whitelisting certain apps, other, multi-factor authentication, all the other things you need to be doing in your org to ensure that you're protecting your data, because you can't protect against every human that might have be tricked by an attacker who does this professionally.
Yeah, absolutely. And the challenge here, and these are big corporations like that we're talking about here. Like maybe there are smaller companies as well, but they haven't been in the news. But these big corporations, they tend to have outsourced support and other outsourced functions. And then when you're working as a contractor for let's say customer support, then somebody calls that, hey, I'm from the big company IT department, and you need to do this change because we're taking this new ticketing system into use. Yeah, I can see why that can work. So there really needs to be the training and human factor. But of course, like there are things that can be done. So when we're talking about access controls, the initial access is what that we've been now focusing on. That is something that can be made difficult, but it's also something that it's impossible to make 100% sure that it is never going to be breached, so that the attackers will gain some foothold into the org is a possibility. So then the question is that what do you do then? And I think a very important thing to understand is that what will the attacker do then? So what do you want to prevent? So when it comes to Salesforce orgs, the attacker, of course, wants to get hands on the valuable data. And the first thing they will do is they will look around, like what can they see? Where did they land? Like what kind of account did they get? What data can they see? And they will also look at something that in the security circles is used. The term is lateral movement. So can they move from this account to somewhere else? Can they move from this org to some other org? Can they move from this org into some other system, like something in AWS or maybe a GitHub account, something like that? So that's very important that the access controls are also in place to prevent the attacker from like making this escalation. And like one simple thing in Salesforce that needs to be taken a look at are name credentials, like who gets to use the name credentials in the Salesforce org. And because if the attacker lands in some sort of like, let's say, account that doesn't have a lot of serious access in Salesforce, but then they can use a name credential that gives them access in some other system. That's quite a problem.
Yeah. So Mika, we have a question from Martin, and Martin, if you want to talk about it instead of just with Mika, you're welcome to as well if you want to get off mute. As we said, this is a very collaborative session here, so feel free to ask your questions, but I'll just read it out loud for everyone first. What Mark's asking here is, how would this fake data loader happen if multi-factor authentication is required in production orgs in general? And was this a social engineering or something else? And I said, yes, it is social engineering, but I mean, that's a great question. I think is like, how, if multi-factor is enabled in the org, how would the attacker bypass that with this data loader app?
So essentially the user has to be logged into Salesforce already. So they will have to have a password and they will have to have an MFA and they have logged in. But if the victim is, let's say, the support agent, they most likely are logged into Salesforce all the time when they're on duty because they're working in Salesforce. So of course they are already logged in. So when they authorize the connected app, they are doing it as an authenticated person, somebody who has access. Does that like make sense?
Yeah, I think that makes sense.
Thank you.
And also, I think just to expand on that too is like, I mean, I think it's the difference between authentication and authorization. So, OAuth, which is what all these connected apps go off for, is authorization. So even if you, for example, change your password, they still have access to your org, because what's happening is you get a token that gets established once that initial trust is established. So if like you're already logged in, then you wouldn't need to go through the MFA. You just, I think you guys are probably very familiar with like Facebook or LinkedIn. You go and say you want to, maybe it's a game or something. It says this app would like to use your information or share your information. You click yes, that's OAuth. And so you would then just accept that. And now it's using your session, and now they've got a token so they can log in with you for as long as you allow it, without having to re-authenticate again. And the way you can stop that is look under your user record at Salesforce, so you can see all the apps that have access to log in as you. And you can revoke their access at any time, but that's actually one way that MFA is kind of bypassed if you are allowing this app to log in as you, and you get that prompt. But I mean, if you say yes and you don't know what that app is and what it's going to do, then you're kind of allowing it to expose that information. But then that's kind of, we're going back to the IP security by default and whitelisting certain apps, where even if you did that, they wouldn't be able to get access to your org because they wouldn't be on your network or on your IP.
Yeah, that is absolutely correct. And something to note really is that, like, if the attacker steals your OAuth token, they might steal it by like tricking you into giving them one, or maybe they steal it from some third-party service where like there is a breach there. They can use that token and it will bypass MFA because, as Matt said, the authentication has already happened. It's an authorization token. And also in a browser, there are these cookies. And depending on the session lifetime, those cookies are already authorized. So if the attacker steals the cookie from your browser, they can take it to another browser and just log in bypassing the MFA. And that's why also while there's no sign in these breaches, at least in the public sources, that malware would be like stealing tokens from browsers here. But that's also like another problem for any browser-based authentication and authorization. So that is definitely the case.
Yep, that's correct. And someone asked another question. I'm not sure what this is, but well, there's a couple things. It says it could be a malware slash bug planted on a device that's in the trusted IP ranges. I'm not sure who presented that, but maybe you could elaborate on that question a little bit more because I'm not sure I understand it exactly.
I think I understood it. So like I think it was answer to your IP whitelisting thing. So if the attacker basically sets up the proxy into like an authorized IP address, then they of course can enter Salesforce from a trusted IP address. I think that's what the question is all about. So that is true. So the endpoint device security is still very important. So it's very important that you only allow accesses from trusted devices. So you have all those things in place as well.
Got it.
I think that's right.
Yeah, and we have another question here. This is diving a little bit now into profile type security in the org and what you should be doing or what you can be doing. And I love this question. This is a great one because something people don't think about is data cloud. So it says, what about security for data cloud? Is it dependent on Salesforce or just on AWS since that's where it lives?
I love this question because I was going to get to that. So one of those things that the attacker will, like, if they know Salesforce, what they will definitely do when they're scouting for like what can they access is their lateral movement. They're looking for OData, so virtualized data access, cross-org connectors, all of this stuff, and nowadays data cloud. So if the Salesforce account that they got into has access to virtualized data from other services, well, they will have access to that as well. So when you're thinking about access controls, it's also important to make sure that the external objects and the data cloud, spaces are like locked down with permissions as well.
Yeah, and I think also that this is important about data cloud and permissions in general is permissions in data cloud do work a bit different depending on what layer you're looking at in data cloud, right? Because you have your data lake objects and you have your I forget this data model object and data source object and data model object, right? So starting for DLO, DSO, then DMO at the top. Data lake is kind of where your landing zone for that initial data, unless you're using zero copy. Then you have some transformations to your data source objects, and finally the data model object, which is more closer to the actual platform level, and those are the objects that are using to report on. From my understanding, and I'm still haven't dug too much into data cloud myself, but you can use profile-based security on the data model object there, what people can see and all that. But in normal users can't get to the other levels like the DLO and the data source objects as well. But admins can. But then this is kind of the thing though, is you can't really segregate easily anyway. There is a way, but not normally, not like just saying, okay, you get access to this table and this table and this table to your admins. If you access to data cloud as an admin, you're basically getting access to all the data in the data source object and the data lake object. Provided there is the caveat that of data spaces where you could say this admin has access to this data space and that's where that DLO and DSO live. But if let's say you only have one data space and then you're bringing in Oracle data with your finance systems, you're bringing in, I don't know, maybe order data from maybe your shopping cart, maybe you have sub admins and they shouldn't be seeing all that data. Well, you can't separate that data for those admins. They just get access to everything. Also, Shield doesn't really cover Data Cloud as well. And so that's kind of another thing, to think about as well, with all the auditing, the encryption, and all that doesn't cover it. So it's really trying to think about with your permissioning, certainly you're starting to use Data Cloud, like who gets access. Because you have, again, your admins who basically can see everything unless you have multiple data spaces, and that's kind of dangerous. And then then you have your users thinking about what data they can access and through Data Cloud because you have all these systems coming in as well. So I don't know, Mika, if you have any other thoughts on that, but that's kind of, one thing that I mean, that question is I've heard a couple times because Data Cloud is still this new thing that a lot of people don't understand exactly how security works.
Yeah, I think that's definitely right. I would really like, because this is something like let's say in the Windows networking world, this sort of lateral movement has been a concept for a very long time. And we should really think about it in the Salesforce security world as well. Like, it's not just about what can you reach inside that org, but maybe access to that org gives you access, let's say, to some sandbox, or if there's an environmental hub, maybe you can just log into another org. And then there are these data virtualization things. Then through name credentials, you can maybe access completely different services. And especially if the name credentials are not configured to be like to the actual endpoint, but for the whole domain, then it might actually give the attacker access to endpoints, let's say in GitHub, like for instance, like connecting accounts into your GitHub account that you don't think about. So it's quite important that these things are locked down. And
Yep.
you mentioned something which is admin. I'd like to take this discussion into
Actually, I'm sorry, one more
yeah.
thing really quick, just as you type now, we have a question about name credentials. I'm glad you touched on that. Like, what are name credentials exactly?
All right. That's a great question. And name credentials are actually a very smart thing that Salesforce has added. So earlier, back in the history, Apex code, for instance, very typically had, for instance, GitHub access tokens or these sort of API keys in the code itself, which is very dangerous because anybody who can read the code can read the key and use it somewhere else. So Salesforce created something that is very similar to for instance, what in AWS is in AWS Secrets Manager. So basically a place where you can put your secrets and then use them dynamically in the code. So basically that the code can read it at runtime from the name credential. So what you would do when you have like a connected app is an inbound integration. But then if you have an outbound integration, it's typically is like a remote site setting or then it's without authorization. But then if it needs those, then you would use a name credential where you both put the URL that you want to connect to and then the credentials, and people cannot read those directly, but they can use them. So your users can log into a like third-party service to check addresses or phone numbers or something like that, but they can't copy the password and log into that service from outside your Salesforce. That's the idea.
Yeah, and I think, and just to make sure that everyone we have varying levels of expertise on here in Salesforce. So for your non-developers as well. So what he's talking about is, in Apex, when you're making a API call outside to another system, you would typically want to you would have some kind of authentication you put in there. It might be an API key or something like that. And a lot of times people would hard code that into Apex, and that's a bad practice. You don't want to hard code anything into Apex. Also, one thing that I know people would do as well is use custom settings or custom metadata types to store those. But those aren't really encrypted at rest as well, so that's not really secure either. They've kind of put some more security around those now that you can actually say, by the profile who can access which custom settings. Where before it was like they were just open to anyone with admin access, which is bad as well. The nice thing I think, with the name credentials, which now I think it's external credentials, but the piggybacks on top of name credentials, is like Mika was saying, is they're encrypted. They're first encrypted at rest, and once you enter it in, you can't see them again. And so that way, and you just put a placeholder basically in your code, and then at runtime, it goes out and grabs those credentials and authenticates, so that all that's done, in runtime instead of being hard coded into the code, and so therefore you're not exposing your credentials to someone that's just looking at the code basically, or even an admin who has access. The other nice thing about the named credentials or external credentials is you can do things like you can set them at an org level. So for the entire org, like let's say you have a shared API that's just an API key, or you could set it at the user level as well. So you have a certain, that a certain user logging in, you could set your credentials, and then that user could authenticate as that user if you have named users that are accessing certain APIs differently. Like one example, for example, like LinkedIn. Like, so you have your LinkedIn account and you would log in, you wouldn't share that with another person because they have their LinkedIn account. But if it's maybe a translation API, then that might be org-wide, and each person may not have their own login to that translation API. So
Yeah,
hopefully that makes
that's
sense.
right. That's absolutely right. But then then there are like other types of access control. Of course, like Salesforce's access model. Well, all access models are somewhat complex, but in Salesforce they're particularly complex because accesses have both permissions and then sharing. So essentially, if you think about Salesforce as a spreadsheet, then essentially the permissions are giving you accesses to individual sheets within that workbook, and then you have field level permissions that give you access to the columns, and then you have sharing rules and different types of sharing mechanisms that give you access to the rows on those sheets, and you basically you have all of these tools to make sure that the accounts have as little access as they need to do their job. And the problem though is that since this is a fairly complex model, you can actually create problems for yourself. So you can even and you need to read Matt's book about about how bad it can get if the experience cloud gets breached. You can have let's say guest user have access to things that even through Experience Cloud, basically anybody can see certain data if you misconfigure permissions and sharing, and then if you do Apex REST APIs, you can also do that problem there. That it bypasses, like you can even code it in a way that it bypasses all the sharing and all that. So you can actually with misconfigured permissions, you can actually also cause the initial breach in a way. That's why the attacker gets access. But once they have access, let's hope that they get as little access as possible. And I would say that yes, there have been many of these cases now in the news about Salesforce data breaches. But I would say that it seems that at least in all of those cases, at least based on the public information, the access control seems to have been relatively tied down, because I don't feel that there has been any cases where admin level credentials would have been accessed, or that the attacker would have been able to sort of destroy the org in a way. So at least there has been some permissions and sharing that the account that they get access to has had, let's say, limited access, but still sensitive data access.
Yeah, I think it's been a variety of different users. In all the data breaches that I've been reading about out there, they haven't really talked about any specific like access levels of users. But like for example, I think in the Coke example, they were able to steal, I think it's 24 million records were stolen. So like, it could be that that was someone with an admin level. But also at the same time, I talked about this yesterday when I was talking at the London users group. meeting, that a lot of time what people will do is you'll just have all your accounts and all your contacts public read write for your internal users. And you would think, hey, that's fine. They're our internal users. We trust them. They're not really going to do anything bad. But what people aren't thinking about is what if that internal user gets breached and they have access to all this data that someone could steal from them. So I think a lot of it is limiting your exposure for any one user. So even if your users really, there's no reason you shouldn't give them access to the data. But go back to that, is there a business need? Do they need to see the data? Because if they get breached, then that data is now a target to be stolen by an attacker. And I think that's the idea that you need to be thinking about for all of this. But we don't know if there were admin users breached, if there were not. Because like pretty much the scary thing is anyone can install really anyone can on top of their app install a connected app into an org. You don't really need I mean, to install a package, you need admin access. But for example, Data Loader, as long as you have API access, you can say, it can redirect you to the right link and then says, this app is trying to use your credentials. Do you want to allow it? Just like you again on LinkedIn. Another thing that people are is kind of scary are plugins in Chrome. So all these plugins in Chrome can either have a connected app, but some of them don't even do that. They just piggyback off your session. So if you install a malicious plugin to Chrome, then that's also using your session, which again is another reason for IP-based security in an org to stop that. Or you get your IT department to lock down what plugins are allowed to be installed in the browsers, which is a bit harder.
Yeah, I wrote a full blog post about risks of Chrome extensions on Salesforce. So go read it. It's a scary topic. The
I do have a
reason
couple more questions, if you don't mind, Mika, that are being posed here. So Dan is asking about flow security. He's saying, is there any way to determine which users are accessing each individual flow within an org? And he's not really dug through it like with Shield event log objects, but he's just curious if you know anything about flows and find out who's accessing each flow. And I think that's a great personally, but
I would be surprised if it's not visible in the event monitoring logs, but I've actually not checked that particular thing ever.
I know, Dan, I know in the event logs Apex, you can see which Apex they're executing. I know some of the Lightning APIs you can see. Again, I would be surprised as well, but in a couple of weeks, we're going to have someone on the call by the name of Beach, and he's going to be talking about Shield. So, and he's a big expert on Shield, so he should be able to have that answer. But also, I'll also put that on the back burner here, and I'll try to see if I can get that answered for you offline. Let's see, and then Martin, I think we'll answer your question a little bit, but I'll let you, Mika, continue with what you were talking about.
All right, so the admin thing, like if the attacker would gain access to an admin account and the attacker would sort of take full advantage of it, they could make life in these breaches really, really difficult because, for instance, what they could do is that they could first go and shut down backups, and then they would wait for some time, and then they would basically kick off every other admin from the org, and then they would start deleting data, and then they would have only the only like fresh backups and things like that. So you really want to make sure that the admin accounts are as locked down as possible. And I've heard horror stories about this in the Salesforce world that there are many orgs out there that have way too many admins. And that's really something that you shouldn't have. And also there are two things: being an admin, but then being an like de facto admin, so that you have the permission to grant permissions. Then if the attacker lands in an account like that, they can just give themselves any permission and essentially become an admin. So it's quite important that the system permissions are locked down so that most users don't have any of the dangerous system permissions out there.
Yep. Here's another great question. I actually like really, this is a really good question. And you might have a little bit more insight into this. It's like it says, I would like to know what are some of the key steps to take to handle internal threats, employees taking screenshots or using mobile to take pictures of data. That's a tricky one.
Uh, that's a really tough one. Like if somebody takes pictures or writes down into a notebook data from the Salesforce, that's something that is of course like quite difficult to know that it happened.
Yeah.
But at least I would say that like in most cases, these internal threats, the the um, the people doing it are not doing it like that. They are actually downloading the data. They're downloading the reports. They're running the reports, and you can see that happening. And usually, like a typical scenario would be that like they have a few days of work left. They're going to another company and they will do it then.
Yeah. I think some other things you could do is this is not really a Salesforce security question, but more of a general IT security question as well. I mean, there is possibility with like an MDM tool or other things like that, you could lock down the ability for laptops to take screenshots, for example. Nothing you can really do about a mobile phone taking a photo of the screen there. I think there's just only so much you can do with that, unless, especially if it's a personal mobile phone. But at least from screenshots and things like that, your IT department can lock that down on there. Um, One other good question here is on a Chrome extensions like Inspector, which are really useful. How would you go about monitoring and ensuring it won't be targeted? And I mean, I think this goes back to IT security again. It's kind of like with those extensions, since they're client side on the browser, it's more about IT being able to whitelist certain apps that are trusted apps, and then others that and black or don't allow others that are not. I think a whitelist is the best thing. It's because I mean, even though it's a little bit more of a pain for your users, but it's going to help ensure that maybe a new malicious app that's not known wouldn't get installed, and only approved apps that we know that work are on there. But I think that goes back to also that thing of, okay, what is, you know, the balance between usability and fun and security. I mean, if something's completely unusable, then no one's going to, it's no, what's the point of even having it? But also at the same time, you just don't want to open the doors completely, otherwise people can steal the data.
I'd like to say a few things about the Chrome extensions. Like
Yeah,
it is a potentially a big problem because it's not just the Salesforce Chrome extensions, but basically every Chrome extension can see all the web pages, so all the information that is there, including Salesforce things. And the Salesforce Chrome extensions specifically, they are typically created by people who are like very enthusiastic about Salesforce and like creating the app for themselves and their friends in the community. Um,
yep,
but there's no real like security vetting or guarantees that there are no vulnerabilities in the extensions. But another problem that hasn't appeared, as far as I know, at least in the Salesforce ecosystem, but has appeared in other Chrome extensions, is that the Chrome extensions can be solved. So if you have a Chrome extension in the store, it's probable that you will get approached by people who want to buy the extension from you with some sum of money. And so if you've been developing it for a long time and then you feel that, okay, I don't want to do that anymore. And then you feel, hey, this person is promising to continue my good development, then you might sell it. And then what the buyer might do is that they will use the Chrome extension automatic update feature to release a malicious version. So a
mm,
Chrome extension that was completely benign becomes malicious. This hasn't happened, as far as I know, with the Salesforce extensions, but it has happened with other Chrome extensions earlier.
yeah, and I think that's similar with like just social engineering in general of like open source repositories and stuff. So if you have an open source extension even, and then someone compromises that, that could then be turn into something malicious. And this is actually a good segue into another question someone's asking about files. What is the best practice in terms of dealing with files uploaded from a guest user or community user through a ScreenFlow? Does Salesforce Shield automatically take care of this, or are there settings for the files object that we can be mindful from a security perspective? So first thing, I think, just to mention here, just in case everyone doesn't know, is Salesforce doesn't scan any file uploaded for viruses. And that's kind of what we do from our company, is virus scanning of your files uploaded to Salesforce. The files that are the most, I would say that the biggest threat is from the outside world. So specifically your digital experience sites, email to case, and your even worse is your guest user. If it's someone authenticated and it's a vetted authentication, not a self-registration, which is a little bit worse, because you can't, you're not even checking their, vetting them, then, at least you're a little bit more protected. Maybe you might halfway trust the person uploading the file. But if it's a guest user, then any attacker could target your environment for any malicious types of files and uploads those into Salesforce. For example, if you have a case submission form or something like that. And so when it comes to flows, guest user, through a ScreenFlow, it's really no different than any other files through any other mechanism you're uploading a file to the guest user. Luckily, Salesforce has a setting that allows you to disable files through uploading from the guest user. So, and I believe that's on by default, Martin. So if the best practices don't allow files uploaded from the guest user. And if you have to upload files in the guest user, then use a virus scanner that's scanning those files so you can assure at least that those files are scanned for viruses before they make it into the hands of your end users. So does that answer your question, Martin?
Yeah, it does.
Okay, great. Let me see here. I think we're good on questions. We are just about out of time. Does we can stand a little bit longer for anybody that wants to stay on. Does anyone have any other last minute questions, or Mika, you have anything you want to share with everyone?
I would just finish that, like when we're talking about the kill chain, when the initial access happens and then the attacker is looking around, the last thing they will of course do is to exfiltrate the data. And in the case of this Data Loader connected app, the initial access at the same time is kind of exfiltration already. But in many other cases, they want to exfiltrate the data with some other means. And something that has also been visible in some of the other Google threat intelligence reports is that the attackers, especially the gangs related to these breaches, they tend to use the same ETL tools that the companies themselves use in order to hide the exfiltration from the logs. Because if you look at the logs and there's, like, let's say Airbyte is being used in the organization, there's traffic going to the Airbyte IP address, and it doesn't look any different if there is another Airbyte account being used. It's just not going to your company's Airbyte, it's going to the attacker's Airbyte, and then from there maybe to an AWS S3 bucket or someplace. So it's quite important to keep an eye on the API logs and how it happens and all of that. And monitoring all of this requires some sort of a solution. We have a solution at Valo AI for this, but you definitely should look at like what's going on in your API logs to spot these things happening. And yeah. So basically, I think we went from the beginning of the attack to the end of the attack in a sense.
Yep, exactly. And we do have one more last question, and then we'll wrap up. That by another anonymous user asking about files uploaded by authenticated users in FormAssembly. I do know that FormAssembly does have a rudimentary virus scanning utility in FormAssembly. I don't know how effective it is. And nothing against FormAssembly. I like them as a product. I I know that most companies that are not dedicated virus scanning companies to that, they don't really go all the way. So what I would do is if you're a form assembly user, talk to them, understand how they're doing virus scanning with files uploaded through form assembly, and make sure that they're scanning more than just the checksum. Make sure that understand what's the source of the database they're using to scan the files. Is it ClamAV, which is open source, but not really that comprehensive compared to like a Sophos or something else, or which is backed by what the database we use. So I mean, that's what I would just say from files using something like form assembly. Just make sure that, or any other provider that says they are scanning files coming into Salesforce, make sure that you know how they're scanning, what database they're using, and there's a lot of other questions. And we actually have a blog on the site that of a lot of questions that you should be asking when it comes to file scanning in Salesforce. Just really quick, just so you know, EzProtect, we sponsor this office hours every week. We're going to have different topics coming here. If you're interested to understand more about files scanning or URL scanning in Salesforce, especially phishing attacks, since that's the latest thing, feel free to schedule an assessment, or if you just want to talk to me. And then we have some other resources here. Securing digital experiences. That's my book here again. This, all profits go to nonprofit, good causes, security for good. So if you're interested in picking that up, there's some more security resources, a bunch of blogs that we've written. We shared Mika's blog link earlier as well. So if anyone's have any questions, we can stand by here to answer. I've got some more time. If not, then thank you so much, everyone. All right. All right. Martin, feel free.
Okay. I just wanted to ask, since we're talking about like Google Chrome extensions, like what would you recommend in terms of extensions like Organizer that can like basically group like Salesforce orgs to sandboxes? Like in terms of protecting like from like browser session cookies or stuff like that from a security perspective.
Um,
So,
Mika, you want to take that?
Yeah. So what do I recommend? Well, first of all, I would if your company is using Chrome, I would use the managed Chrome so that you can define which extensions are in use, and you wouldn't allow all extensions, only the ones that you have vetted and trust. So it's a matter of attack surface. There is risk with any software, but to keep that to a relative minimum, and then of course only allowing devices with have proper malware protection and security updates and all of that to connect into your environment. So these are the kinds of things, but I wouldn't go as far as to recommend any particular extension. It's just you need to do your own assessment based on how much value does it bring you and how much risk does it bring you and whether or not you're comfortable with that. And there's like a different risk appetites to different organizations.
thank you.
Great. Does anybody else have any questions before we wrap up? Just want to give everyone an answer because it's part of this office hours is getting your questions answered. So nobody else has any questions, then all right. Well, I guess that's it. Well, thank you so much, everyone. If we'll be doing this again next week. Next week, I believe I'll be talking about your App Exchange packages and how to perform better security reviews in your App Exchange packages. And week after next, we'll have someone talking a deep dive into Salesforce Shield, and so you can ask any questions from a Salesforce Shield expert. So thank you again, everyone. I appreciate the time, and hope to see you next week.
Thanks so much.